So I'd like to introduce myself. My name is Ryan Boyer. I'm the program manager here at the Edison Ford Winter Estates. Again, I'd like to thank you all for joining us this morning for this month's edition of Step into History Digital Edition. The idea for this talk came about a month ago when GE was in the news talking about its imminent breakup into various divisions. And I got to thinking about how many people realized that Thomas Edison was actually involved and actually kind of a principal founder in General Electric. Albeit by the time it became GE, Edison's influence was waning. But his actions in the decade previously really set the stage for the creation of, at least one of the United States' major industrial conglomerates in General Electric. So with that, I'd like to just kind of jump right into this. Again, this is our Step into History digital edition. Today, the topic is After Incandescence, the Rise and Fall of Edison General Electric. All right, so in 1876, Thomas Edison would leave Newark, New Jersey. He had spent the last 6 to 7 years building a reputation as one of America's foremost inventors in the field of telegraphy. Edison's stock ticker, his private line printer, quadruplex telegraph, had all earned him enough money to set up a series of small workshops in Newark, New Jersey, to develop and manufacture his inventions. However, ultimately issues over rent, and according to Edison, he couldn't get any peace and quiet in Newark and was run down by visitors. And so he decided to purchase land 12 miles south of Newark in a small country hamlet along the Pennsylvania Railroad between New York City and Philadelphia. You can see the Pennsylvania Railroad line here on the left. So here, he purchased 34 acres of land for $5,200. He'd spend another $2,700 constructing the two-story, 5,000 square foot laboratory you see on the left. He would go on to spend an additional $40,000 outfitting the lab with every conceivable apparatus and material for scientific research. In 1876, Menlo Park was state-of-the-art and unparalleled in the United States. And here at Menlo Park, Edison planned to create a minor invention every 10 days and a big thing every 6 months or so. To give you a look inside the lab, on the ground floor, as you entered, there was an office and a library that led to a large room, really, that was filled with patent models and various inventions of Edison. By 1876, he had already secured 100 US patents. The rear third of the ground floor, which you see here on the left, was his fully equipped machine shop. On the right, you can see the second story. The laboratory occupies the entire length and breadth of the building. As you can see, the walls are covered with every conceivable chemical and material needed. Throughout the lab were tables covered with instruments like microscopes, spectroscopes, vacuum pumps, batteries, even a pipe organ seen at the back. When Edison opened Menlo Park, he did so with only 5 muckers. That's what he referred to his employees. They were experimenters Charles Batchelor, who's actually the individual seen here underneath the light, James Adams, and machinist John Crucy, as well as Charles Worth and Tony Bronk. All of these men had been with Edison during his manufacturing days in Newark. According to Edison, it cost approximately $100 per week to run the machine shop and to pay all his skilled workers. Most of this early funding for the lab came from contractual work between Edison and Western Union, specifically on the telephone and multiple telegraphy. By 1878, when Edison embarked on his incandescent light bulb, he was already employing 25 men, including experimenters, chemists, lab assistants, machinists, pattern makers, handymen, watchmakers, bookkeepers, and private secretaries. A year later, that number would jump up to 40 employees, including PhDs, more experimenters, chemists, lamp blowers, steam engineers, draftsmen, lab and office assistants. This is also when Francis Upton joined Edison. He was the recipient of the very first Master of Science degree from Princeton University and was instrumental in the development of the light bulb at Menlo Park. Lastly, at its peak in 1880, when Edison was making tremendous strides on the development of his system, He employed close to 60 employees at Menlo Park. Edison's state-of-the-art lab and collection of brilliant minds and expert machinists gave Edison a tremendous advantage over other inventors. In fact, in his first 2 years at Menlo Park, Edison created improvements in multiple telegraphy and telephony, an improved telephone transmitter, the phonograph, an electric pen, a mimeograph, and devices to measure heat and amplify sound. In all, Edison successfully execute 44 patents during this time period. This is 1878 at this point, and this is really where the story of Edison and the incandescent light bulb begins to take shape. You might have remembered our recent total solar eclipse here in the United States. Well, back in 1878, there was a total solar eclipse as well. And stories began to run in the US papers about the event. And just like today, you have here an example. There's Scientific America. They ran a story on the total solar eclipse that would traverse the western frontier. They talked about how Edison was going to use his newly created tachymeter, which is pictured here. You can see the brief description on the left, but in essence, there was a little carbon diaphragm here in the middle that would react to infrared heat, basically be registered the small changes. In any case, the idea was that Edison was going to use this tachymeter to measure infrared heat and to try to discover stars that were unseen with a telescope. You can see Edison pictured here on the right with his arms crossed. There's a chicken coop over his shoulder where he set up his tachymeter to conduct his experiments. You really don't hear much about the tachymeter today because his experiments were inconclusive, either because the device was far too sensitive to be accurate, or because he set up his device in the entryway of a chicken coop during a total solar eclipse, which mimicked nightfall. You can imagine what happened when all the chickens came back to roost as Edison was set up in the doorway. Like most of the stories surrounding Edison, the truth probably lies somewhere in the middle. In any case, during this trip, there was much discussion on scientific matters and advancements, and the topic at one point turned to Wallace & Sons, pictured here. Wallace & Sons was a leading brass and copper foundry in Connecticut. They produced bronze metal library lamps, brass buttons and fasteners, ornamental harness loops, rolled metal, drawn wire. Their discussion, however, was less about Wallace & Sons products and more so on the extensive arc lighting system that was employed at the foundry. If you're wondering what arc lighting is, basically it was one of the first commercial electric light sources. In essence, electricity would arc between two carbon rods and produce a high-intensity ultraviolet light. Arc lamps produced a super bright light that were capable of illuminating large areas like factories and city streets, but far too bright for private homes. Despite being invented in the early 1800s, it wasn't until the 1870s, when electric generators were being manufactured, that arc lights became more practical, and this period would end up being dominated by the Brush Electric Company. You can see here that their first installation was actually in the Wanamaker department store in Philadelphia in 1878. And in 1879, the very first public light system set up in Cleveland, Ohio. By 1881, major cities across the country had these arc lights. You can see New York City on the right, Los Angeles on the left. In between, you had Detroit, Cleveland, a number of US cities with these bright lights. To some extent, the growth of the electric arc lighting was a consequence of the 1876 Centennial Exposition in Philadelphia. In 1876, the United States hosted the World's Fair in Philadelphia to celebrate the 100th anniversary of the signing of the Declaration of Independence. It marked the first official World's Fair in the United States, and it highlighted American ingenuity. Mass production was on full display here. Sewing machines, typewriters, stoves, lanterns, guns, agricultural equipment were all on display. Inventors Alexander Graham Bell showed off his telephone. Edison displayed his automatic telegraph system and his electric pen. Even Westinghouse was there, not for AC generators, however, but for his locomotive air brakes. Manufacturers who visited Philadelphia would order thousands of state-of-the-art machines for boosting productivity and for reducing costs. They also went home with innumerable ideas for making their factories run more efficiently. The images you see here are of the over 500,000 square foot machinery hall, which was filled with 8,000 working machines. They were all powered by the 70-foot tall, 1,400 horsepower coreless steam engine that's pictured on the left as well as in the center here on the picture on the top. There were 5 miles of overhead belts, shafts, and pulleys to drive these machines. The point is, by 1876, the United States was primed for industrial activity. Not only was industry primed, but capital was eager too. Contacts from Edison's time on Wall Street in the early 1870s were reaching out, encouraging Edison to look at electrical matters. On the left is a newspaper clipping sent from James Banker, the president of the Gold and Stock Company. He basically sent a series of letters drawing attention to Edison for the electric light display of arc lighting in Paris. He sent a series of letters really through 1877 and 1878, congratulating Edison on his successes at Menlo Park, while also noting that according to the press, the only considerable money Edison had made in recent years was in the 1870s when he introduced the stock ticker and made some $40,000. Banker was generous enough to offer to represent Edison's recent phonograph and telephone interests in Europe, and hoped that Edison would give the idea of electric light some thought, as Banker expected more money in it than anything else. On the right, you see a cartoon of Edison's investigation of the Metropolitan Elevated Railroad. The Metropolitan Elevated Railroad began operation in June of 1878. By the end of July, there was already complaints about excessive noise. There was a grand jury investigation, and there was a threatened lawsuit as well. Grosvenor Lowry, who was the railroad's attorney, as well as Western Union's general counsel, and Edison's patent attorney since the 1870s, arranged for Edison to investigate the source of noise along the line. Edison worked with his machinist, Charles Batchelor. They would spend a few weeks in July riding the trains, walking the tracks, climbing the trestle work. Edison even had staff at Menlo Park modify the phonoptograph, which was not Edison's invention. But they basically adapted this machine to make visible, permanent record of sound vibrations. This whole event was widely covered in the press. So in addition to the cartoon depicted here in the New York Daily Graphic, there was numerous articles ran by the New York Daily Tribune, the New York Herald, and the New York Sun covering Edison's investigations. Lowry, like Banker during this time, also pressed Edison to get involved in electrical matters. So by the time Edison traveled out west to view the total solar eclipse, he was already a recognized, successful inventor with a state-of-the-art invention factory and eager supporters both in the media and in industry. So, days after his return from out west, one of the professors on the trip, George Barker, he was a physics professor at the University of Pennsylvania. He invited Edison to go to Wallace and Sons to view the arc lighting system. They were both interested in Wallace's generator, which he referred to as a telemecon. Wallace hoped to use his machine to transmit power electrically over great distances. A reporter from the New York Sun actually accompanied them on their trip, and he wrote that Mr. Edison was enraptured. Power was applied to the telemecon, and 8 electric arc lights were kept ablaze, one at a time, each being equal to 4,000 candles. He ran from the instruments to the lights, and from the lights back to the instruments. He calculated the power of the instruments and of the lights, the probable loss of power in transmission, the amount of coal the instrument would save in a day, a week, a month, even a year, and the result of such savings on manufacturing. Within days, Edison filed a series of caveats, basically preliminary patents, not as doesn't require as much, you could say, evidence as a patent would, simply noting that they are going to be working on this was his caveat. He had basically outlined how he was going to subdivide light using what he called thermoregulators. That's pictured here on the left, these various devices, these coiled up springs in essence. The idea is that with his thermoregulators, he would prevent the incandescing element of his lamp from melting. This system was actually analogous to the way he designed telegraph instruments, specifically the electromagnetic switches in multiple telegraphy that allowed him to send messages, multiple messages in multiple directions on a single telegraphic circuit. On the right, you can actually see his entire system on display. The thermoregulators in use here are depicted, as well as the box on the right. Figure 1 is the box in the top right corner. That was simply labeled the electro generator. So in essence, he was just going to simply wire, just like in this telegraph circuit, these thermoregulators together, and instead of a battery, as you would do with the telegraph circuit, just simply supplement it with one of Wallace's arc dynamos. You can see here, even on the 13th, he would send a letter to Wallace telling him to hurry up the machine, that he had struck a big bonanza. However, Edison would soon learn that the current dynamo designs were incompatible with his plans, primarily due to their inherent inefficiency in converting mechanical power to electricity. So the idea here is that 1878, after visiting Wallace and Sons, seeing this on display, basically jots down on paper a few of his ideas and says he has it figured out. In fact, a week later, the Sun would actually help him get this message out. The Sun would publish on September 17th, 1878, a news story titled Edison's Newest Marvel, outlining how Edison was going to use a single 500 horsepower engine and 15 to 20 Wallace dynamos to distribute electricity underground and use existing pipes and fixtures to carry his electric wires and hold his lamps. However, very few specific details were provided on how he would achieve this. Undoubtedly, it would require a large sum of money to span the developmental distance required to make all of this possible, considering most of the components of this system didn't even exist yet. And for Edison, he was already running into trouble. At the time, he was burning through money, what little money he had left after setting up Menlo Park. Patent expenses from his work on the incandescent light bulb were mounting, as well as costs to run the experiments. You can see here he owed over $200 in patent expenses, $750 for the dynamo that Wallace would send him. You have money owed to a jeweler for iridium, which is what he was originally using as a metal, as well as additional chemicals and materials. So this is actually where Edison's old alliances would step in and fill that need. All of the media frenzy about Edison's electric light system generated considerable interest among several groups of capitalists, most notably those associated with Western Union. Western Union had actually turned down Bell's offer to sell his telephone interests. Now, no money in the world could sway Bell to sell to Western Union. Grosvenor Lowry, with his connections to Western Union and Edison's Trust, was well positioned, both figuratively and literally, to handle the negotiations needed to fund Edison's enterprise. In addition to his Western Union connections, Lowry's law firm, Porter, Lowry, Soren and Stone, was actually located on the 3rd floor of the building on 23rd Wall Street, where Broad Street meets Wall Street, the Drexel building, the headquarters for Drexel and Morgan and Company, J.P. Morgan's eventual banking house. Edison placed his full trust in Lowry to get the job done, writing, "Go ahead, I shall agree to nothing, promise nothing, and say nothing to any person, leaving the whole matter to you. All I want at present is to be provided with funds to push the light rapidly." These negotiations would actually lead to the formation of the Edison Electric Light Company, which was incorporated in New York City on October 16th in 1878. The Edison Electric Light Company would provide monetary support for research and development in exchange for control of Edison's patents. In a letter to an associate, Edison wrote, "The electric light is going to be a great success. I have something entirely new. William H. Vanderbilt and friends have taken it in, and on Monday next, an advance of $50,000 to conduct experiments." A reoccurring theme, however, throughout the history of the Edison Electric Light Company was Edison's penchant for burning through cash and the board's unwillingness to provide Edison with endless funds. You can see here that the initial payment was actually half of that $50,000 that Edison expected. This was basically a reoccurring theme throughout. Edison would regularly refer to the company as the leadened collar around his neck. You can see here on the left, though, It was incorporated with $300,000 in capital stock. Board seats were given to the initial investors, and the board would basically establish royalty payments and cash disbursements to Edison as long as it was successful. Those involved with the formation of the Edison Electric Light Company and were seated on the board originally were Norvin Green. He was the president of Western Union and served as the Edison Electric Light Company's first president. Agistio Fabri, he was a partner of Drexel and Morgan. He would serve as the first treasurer. JP Morgan was an initial investor as well, but did not retain a seat on the board. However, Drexel Morgan and Company were the bank of the Edison Electric Light Company. Other members did include Thomas Edison and Grosvenor Lowry, plus the members of his firm. Hamilton Toombley, he was the son-in-law of William H. Vanderbilt, the son of Cornelius Vanderbilt. He represented the Vanderbilt's interests. They were heavily involved in gas utilities, as well as a majority shareholder in Western Union at the time. Tracy Edson also joined. He was another member of Western Union, as well as James Banker from Golden Stock, which was actually a subsidiary of Western Union. So quite a well-connected and financially successful syndicate. Over the next 2.5 years, the Edison Electric Light Company would provide Edison with $130,000, approximately $3 million today, for research and development of Edison's system. One of the first actions taken by Edison after the formation of the Edison Electric Light Company was to expand his research and development facilities at Menlo Park. With funds from the newly formed company, Edison built and fully equipped a large brick machine shop pictured at the top left, as well as at the top there. Edison used Babcock and Wilcox to build and supply power to the machine shop. At the time, they were a well-respected manufacturer of steam boilers and were actually awarded the gold medal at Philadelphia's Centennial Exposition for their 150 horsepower cast iron boiler. Additionally, he constructed a 2-story brick office and library pictured here at the bottom. He would fill it with over 500 books and journals. He would also add a few small wooden structures to the building, mainly pictured over here on the right. These included a carpentry shed, a blacksmith shop, a carbon capture shed, basically where carbon soot from perpetually burning kerosene lamps was collected. He built a glass blower's work shed as well. He also converted the bottom floor where the old machine shop / library / office space was of his laboratory into additional workspace for experimentation. Edison's extensive research and development facilities gave him a tremendous advantage over other inventors. He could rapidly construct, test, and alter experimental devices, significantly increasing the rate at which he could develop his ideas. Using a team of researchers, he could work on different parts of the problem or even completely different projects all at the same time. Now, to address a common misconception, Edison did not invent the light bulb. In fact, he's the 24th or 25th inventor of a light bulb, depending how you count. You can see here on the left. Edison did not just invent components, he invented a system. Light bulbs were useless without a reliable and economic electrical distribution system. This is why you're more likely to see Thomas Edison's name associated with the light bulb, not the 20+ individuals you see here. At Menlo Park, Edison did invent an entire system, however, not just a light bulb. Each step in his quest for illumination informed the next. His early experiments on thermoregulators using platinum directed Edison toward placing his metal filament in a vacuum bulb. Attempts to create a better airtight seal led them to create better vacuum pumps than were commercially available at the time. His improved vacuum actually enabled him to dispose of his thermoregulators altogether. They weren't even needed now because the filaments did not need to be prevented from melting. All the while, Edison was using platinum because of its high melting point, which at this point was no longer necessary for the filament not to burn up. With his improved vacuum, Edison was able to substitute carbon, which was much cheaper and readily available, further increasing the economy of the bulbs. And concurrent with all of this experimentation on the design of the light bulb, there was just as much effort going into research and development on generator designs. Originally, Edison assumed he would use Wallace's arc light dynamos for his system. However, experiments soon revealed inherent inefficiencies in current generator designs. Current generators were designed to provide maximum current, which was adequate to power arc lights. However, in Edison's proposed system, he required a constant, steady current, a dynamo designed for efficiency, not current delivery. By the beginning of 1879, after, as Charles Batchelor put it, a few weeks hard study on magneto-electric principles, he was leading the machine shop in the design of a new high-efficiency generator. By July, the team had created a dynamo that delivered, in the form of current, 96% of horsepower applied to it, compared to the 60 and 70% of traditional dynamos. Francis Upton, in a letter to his father, noted that we now have the best generator of electricity ever made, and this in itself will make a business. All of this was achieved in the span of a year, as Edison said, working day and night on the electric light. It might sound like a trendy slogan or just a saying, but in essence, they truly worked day and night, with the machine shop working all day long and the laboratory working all night long. By year's end, Edison began to hold a series of small demonstrations of his electric light system, first to directors of the company and prospective investors. Later, even movie stars came to visit. Grosvenor Lowry actually invited aldermen from New York City to view the demonstrations to try to sway them to allow the Edison Electric Light Company to tear up city streets and install electrical wires and conduits to deliver electricity to consumers in lower Manhattan. The events were a tremendous success, paving the way for ultimately his grand demonstration. By the end of the year, media frenzy was building over his electric light. You see here a number of articles here on December 30th about Edison's electric light stock, talking about how the stock had risen to about $1,000 to $4,000 per share. The nominal value when these shares were issued were $100. So there's excitement building in the stock market. There's another one on the right here, talk about the Aladdin of American science begins to stir money market, talk about a heavy fall in gas stocks. So there's truly a frenzy building in the media and financial circuits. And then New Year's Eve, 1879, Thomas Edison at Menlo Park demonstrates to all his incandescent light. He would have hundreds of onlookers from far and wide descend upon Menlo Park to view his display of just over 400 incandescent light bulbs. They're spread throughout the laboratory, the surrounding buildings, the adjacent homes, the streets, and the fields. They stayed lit for hours. They were impressed attendees with their brightness, with their stability, and the nice calm light that they gave off. Visitors were able to witness firsthand the transition from gas lighting to electric illumination. The success of his demonstrations at Menlo Park encouraged the Edison Electric Light Company's board to establish an arm of the company to construct a central power station in Lower Manhattan to provide electricity and serve as an inducement for others to purchase franchises and components of the Edison system. Coincidentally, the area they chose to illuminate was not just an adequate blend of commercial and residential buildings. It was also the financial capital of the United States and home to several influential newspapers like the New York Times. However, it turned out that Edison's Menlo Park demonstrations created quite a buzz for owners of small factories and farms, as well as residents of small towns and wealthy individuals. Within weeks of the new year, the Edison Electric Company was inundated with requests and inquiries about installing isolated units similar to the one displayed at Menlo Park. By the end of the following year, 1881, the Edison Electric Light Company would create the Edison Company for Isolated Lighting to sell these small generating plants to the public. By the time Pearl Street was completed in 1822, there were 221 isolated units in operation in the United States. After Pearl Street's first year of operation, 334 isolated units were producing power for electrical lighting in factories, foundries, and farms and small towns across the United States. However, Pearl Street was Edison's primary focus at this time, not isolating units. For this project, Edison and his team actually developed a 27-ton constant voltage dynamo that produced 100 kilowatts and could supply current for 1,200 lamps. You can actually see them pictured here on the left. There was 6 of them employed at Pearl Street Station. They would lay 80,000 feet of underground conductors to deliver power to the initial 85 customers, powering only 400 light bulbs initially. Edison had envisioned Pearl Street as a showpiece designed to promote central stations all over the world. In this respect, however, it was a failure. Investors by the scores read about the achievements at Pearl Street, they marveled at it, and they kept their money in their pockets. For one thing, it was extremely capital intensive. Pearl Street's initial construction costs alone were approximately $300,000. And again, this is in 1882. Operating costs as well exceeded income for the first 2 years. Pearl Street did not reach profitability until 1884. At this point, the rift between Edison and the patent holding company would begin to widen. The Edison Electric Company at this point was impatient for profits. That had spent 4 years without a return on their investment. Now they demanded that Edison promote only isolated units. Edison refused, having demonstrated the viability of central power stations with the success, albeit unprofitable at this point, operation of Pearl Street. Edison would actually set out to found an entire industry with Pearl Street as its model, and he would do so without the help of the patent holding company. In May, Edison would establish the Thomas A. Edison Central Station Construction Department. Edison's company would construct 13 central power stations, primarily in the Northeast. On the left is the Brockton Edison Electric Illuminating Power Station. It was one of the first projects completed. This building and this entire project was spearheaded by Frank Sprague. He was an electric engineer who was hired at Edison's Machine Works. He and Edison would kind of have a tumultuous relationship. Sprague would eventually leave the company. We'll actually see him come up later on. But this project seen here, like most of the others outside of the city of Brockton, was funded by the various cities that these power stations were constructed in. There was clearly support for Edison to establish these. And in fact, after a year and a half, Edison's Central Station Construction Department was absorbed by the Edison Company for Isolated Lighting. So his company that he started would be taken over by the patent holder's licensee company, the Edison Company for Isolated Lighting. Now, it might seem odd that Edison would go out on his own and basically go against his own interests in terms of the patent holding company and go out on his own and just kind of strike his own line. But in fact, there was historical precedent for this. Back in 1880, after Edison had successfully demonstrated his system at Menlo Park, he actually approached the board for, in fact, millions of dollars to fund the manufacturing arm that would be needed, basically, to create all of the products that Edison was going to need. Ultimately, the Edison Illuminating Company would deny these efforts. They preferred to hold licenses and patents rather to invest directly in factories needed to make equipment for his electric light and power systems. You can see Edison's response here to the board on the left. This is to the president of the Edison Electric Light Company. If there are no factories to make my inventions, I will build the factories myself. Since capital is timid, I will raise and supply it. The issue is factories or death. So in 1880, Edison would establish the Edison Lamp Works and transform a barn near his Menlo Park laboratory into the world's first factory to mass produce light bulbs, incandescent light bulbs. Edison's Lamp Works began as a partnership with Edison as the majority partner and Charles Batchelor and Francis Upton as junior partners. Each member would provide startup capital and provide additional funds for operations and expansion, totaling $250,000 by 1883. And again, this is in 1883 currency. At Menlo Park, the factory had over 100 workers and could turn out 1,000 lamps each day. However, it rarely did so because there was no commercial need for so many. Yet, desperate to bring down the costs, the lamp factory was actually relocated to Harrison, New Jersey in 1882 to benefit from its larger production facility and proximity to Edison's offices in New York City and his work on Pearl Street, as well as the increased labor pool in Harrison, New Jersey, as opposed to Menlo Park, New Jersey. After Pearl Street opened in 1882, the Lamp Works production grew steadily and production costs declined. By 1884, the Lamp Works pictured here was finally profitable and the partnership would become a formal corporation. In 1881, Edison organized a company to manufacture his dynamos as well. It was another partnership. This one was between Edison and Charles Batchelor, again with Edison, the majority partner. It was called the Edison Machine Works. The two contributed close to $150,000 to buy the building pictured here, refurbish it, and equip it with machinery and tools. The Machine Works shipped out its first dynamo in 1881, and by 1882, it had built 9 of the jumbo dynamos used for Pearl Street and 300 dynamos used for isolated lighting. By 1833, there were orders on the books for dynamos totaling over $350,000. In 1884, the partnership was incorporated with Edison as president, Batchelor as treasurer and general manager, John Crucy as assistant manager, and a new addition to Edison's team, Samuel Insull, as secretary. In 1886, Edison would instruct his assistant and Samuel Insull to look for expanded facilities outside the city to relocate the machine works to. At this point, the Edison Company for isolated lighting was selling franchises all over the country, and central stations built by Edison were spreading too. Consequently, the machine shop was booming with business, so much so that workers were forced to run lathes and other equipment on the sidewalks. Insull chose the site of a failed locomotive works in Schenectady, New York, and was instructed by Edison to run the whole thing and, to quote Edison, make it either a big success or a big failure. Luckily for Edison, it was a success. In the first 2 years alone, sales quadrupled. However, every single penny of profit went to expanding the facility. Without any outside capital, the Machine Works was forced to raise all of its operating capital for manufacturing, as well as fully fund their research and development. And this was the case for all of Edison's companies. When Insull moved the Machine Works to Schenectady, they were employing 200 people. The workforce by 1888 would reach 6,000. Now, how about those 80,000 feet of underground conductors? They were actually designed and manufactured by the Electric Tube Company. It was formed in 1881 as a corporation by Edison with 2 members of Drexel and Morgan and Company, as well as muckers Stockton Griffin, Charles Clark, and John Crucy, who also managed its operations. The Electric Tube Company manufactured and oversaw the installation of the tubes that delivered power from Pearl Street Station and fabricated conductors for central stations in the United States, as well as London and Paris. By 1882, it was employing 100 men at its Brooklyn factory, producing a half mile of tube per week. The picture on the left here is actually them laying these tubes and filling these junction boxes with this insulating material that they developed as well. Now, to manufacture the sockets, fixtures, fuses, switches, instruments, and related components, Edison actually bought into an existing partnership of Sigmund Bergman and mucker Edward Johnson. This company was known as Bergman and Company. Bergman would relocate to the facilities you see here in 1882 and expand from a workforce of 50 to just over 300. On the left, you can see one of the meters manufactured for Edison by Bergman and Company. You can see a few of these in our museum, some actually designed by Edison General Electric Company and Edison Machine Works as well. So by 1884, Edison's manufacturing concerns were largely profitable. They had worked out most of the technological bottlenecks that hindered productivity and growth. An enormous amount of capital had been expended, and now profits were finally flowing. Naturally, the Edison Electric Light Company started showing interest in Edison's profitable manufacturing concerns. Edison viewed it as a perfect opportunity to gain control of the company, or at least make it less of a leaden collar around his neck. Samuel Insull, then 22 years old at the time, would actually lead a successful fight for control of the company against J.P. Morgan and Vanderbilt's interests, securing enough proxy votes to oust Eaton, the Morgan-backed president, and the dismissal of enough directors to give Edison a majority and to place Edison's mucker, Edward Johnson, as president. Morgan did remain not in control, but did remain on the board. But the Vanderbilt Western Union back of the board was sent packing. Edison's victory, however, was fleeting because the industry that he helped build was about to change dramatically. In 1886, the streetcar would make its debut in the United States, and instantly central power stations became much more profitable. No longer was power generation a full-time business with half profits. The increased daytime load contributed to a rapid growth of central power stations, and by 1888, Edison could boast the construction of 169 central power stations across the United States, from just 13 5 years earlier. Despite the success of Edison's central power stations, there was trouble brewing on the horizon, mainly that in the form of competing central power, high voltage alternating current. Up to this point, Edison had promoted low voltage direct current. Every component in his system was based on low voltage direct current. In 1885, however, William Stanley would create a practical transformer that was relatively easy to produce. This transformer was essential for transmitting high voltage over long distances by stepping up or increasing the voltage, and additionally being able to make it safe to power homes and businesses by stepping down or decreasing the voltage. In 1886, William Stanley would use his transformers in the electrification, of downtown Great Barrington, Massachusetts. This was the first demonstration of full AC power distribution system using step-up and step-down converters. Westinghouse would later acquire the rights to this device. Stanley would go on to start his own company. Today, fun fact, you see Stanley everywhere. Not just in Transformers, but actually in all those people you see walking around with those little mugs. That is the same Stanley, actually. All right. So in 1888, The manufacturing business for Edison was absolutely booming as a result of this demand from streetcars. Business, in fact, was almost too good. The machine works at this point would have, at one point, orders on hand requiring over $200,000 in copper and zero money to purchase it. The problem with the machine works was that, again, they had to fund everything. Edison would actually take out loans for to cover payroll. Drexel and Morgan would be generous enough to provide loans at 20% interest. And so they were in very financial dire straits at this point. Edison even stated that the danger was not that they wouldn't have enough business, but that they wouldn't be able to grow fast enough to handle it. Luckily for Edison, just as when he was on the brink of making a breakthrough on his electric light bulb and needed money to push through, Edison was rescued by another outside source of capital, this time in the form of Henry Villard. Villard was a railroad magnate and financial speculator who was an early investor in the Edison electric light. He had made and lost a fortune a few times. After his most recent financial disaster, he went back to his home country, Germany. In 1888, he would actually reemerge in Edison's life with financial backing from Deutsche Bank, as well as the German General Electric Company, and financial investments from inventors Siemens and Halske. He brought with him a plan as well to consolidate all of Edison's manufacturing enterprises with the Electric Light Patent Holding Company and Sprague's Streetcar and Motor Company. According to Edison, oh, sorry about that. According to Edison, he accepted the terms of the merger because he was afraid that we might get into trouble for a lack of money. Therefore, we concluded it was better to be sure than to be sorry. Edison, Insull, Batchelor, and Upton became directors. The 5 other seats were appointed by Villard and J.P. Morgan. The newly integrated company was supposed to achieve better operating efficiencies and help finance the construction of central power stations in major U.S. cities. However, consolidation progressed much slower than anticipated, and patent disputes threatened expansion. Edison's first mover advantage that he had enjoyed had been lost. Most of the problems afflicting the industry at this point were no longer technical, but rather managerial, and there were 2 well-managed competitors that were taking share from Edison. You can see here that the Edison General Electric Company would be formed in 1889 with a capitalized stock at $3.5 million. Edison's manufacturing enterprises that were brought in were the Lamp Works, the Machine Works, Bergman and Company, Sprague Electric Railway, and the patent holding company, the Edison Electric Light Company. Fun fact, the Edison Electric Illuminating Company of New York, which made Pearl Street possible, was not part of this. That company would actually merge with the company and lay with the Consolidated Gas of New York, and they would become Consolidated Edison, or Con Ed, which is still around today. But they were not involved in the creation of Edison General Electric Company. So on to those competitors of Edison. Some most notable threats during this period were, of course, Thomson-Houston Company and Westinghouse. Basically, through a series of purchases of virtually every single non-Edison electrical patent. Thomson-Houston, the larger of the 2, they gained controlling interest in the Brush Electric Light Company, which was dominant in the arc light industry. They also owned Swan's incandescent light bulb patent. You remember Edison, 22nd, 23rd, inventor of that light bulb, Swan. He had an English patent for an incandescent light bulb. Uh, Thomson Houston also acquired several smaller companies that produced components in the electrical industry as well as power generation. They even acquired the Van de People Electric Manufacturing Company. They were the makers of the first successful streetcar system. You can see in this is about 1888, the gross annual sales at the bottom there, $10 million. 1888, Edison General Electric, gross annual sales, $11 million. So really nipping at the heels of Edison General Electric. Westinghouse was another competitor. They owned the rights to Sawyer Mann Electric Light Company, which again, another incandescent light bulb patentee. Westinghouse also acquired the rights to Stanley's transformer, which made it possible to change voltage levels, making it safe to distribute to consumers. And probably even more importantly, Westinghouse acquired the rights to Tesla's AC polyphase patents, which enabled Westinghouse to transmit electricity over long distances with minimal loss. You can see here, however, it was a much smaller company. It did have superior AC technology. However, its gross annual sales were half that of Thomson Houston. Before the ink was even dry on the agreement to form Edison General Electric, Villard had actually began to enter into secret negotiations with both Westinghouse and Thomson Houston to acquire one or both of the companies. The reason was that Edison GE, sans Edison, believed that AC equipment was necessary to balance and diversify Edison GE's line of products. Westinghouse was the obvious target because it was small enough to acquire outright. But if Villard could acquire Thomson Houston, he'd be closer to his vision of controlling the central station businesses of the United States. In 1891, an appeals court would actually rule in favor of Edison General Electric, invalidating other lamp patents and granting Edison GE legal power to collect back royalties, which were estimated by the Edison attorneys at $15 million. Villard would break off negotiations with Westinghouse and would go after the larger Thomson Houston instead. With this result of this patent litigation, Thomson Houston was in big trouble due to their use of Edison patents. Not to mention, they had spent millions of dollars on this patent case. Villard would break off the negotiations and would reach out to Charles Coffin, then president of Thomson Houston, to begin negotiations. However, he would be outmaneuvered by J.P. Morgan at the last moment. Instead of Edison General Electric acquiring Thomson Houston, as Villard had propositioned, Thomson Houston was now going to take over Edison General Electric with the help of Morgan. Morgan and Coffin went over the books, and they basically decided that due to the heavy debt load of Edison General Electric, primarily because bankers and financial interests or the financial situation of Edison was such that he was required to raise his own funds. They actually had $3.5 million floating debt, Edison GE. As a result of this, Thomson Houston, for the sake of this merger, was valued at $18,400,000 and Edison GE $15 million, thus giving Thomson Houston men control of the new company. You can see here, this new company would be capitalized at $50 million. These were two of the largest companies in the electrical industry. This consolidation was driven by a desire to pool patent rights commit fully to AC technology, and achieve economies of scale. Charles Coffin, for his role, would actually become the first president of the General Electric Company. Edison would basically secure a board seat on this company. Didn't attend any board meetings. He would net $5 million on the deal. Again, 1892 currency. General Electric would become one of the 12 companies listed on the Dow Jones Industrial Average when it debuted in 1896. As for Villard, he was told by Morgan that his courteous resignation would be courteously received, and so he walked. Edison, again, would receive a position on the board of the company. He would not be active. However, ultimately, he would be forced out from the business that he had created. However, the truth is, Edison had already moved on. In 1878, amid his work on the incandescent light bulb, Edison patented his phonograph. He would put it aside to push the electric light, but he'd return to the phonograph in 1888. This picture here was taken outside his newly built invention factory in West Orange Laboratory, in West Orange, called the West Orange Laboratory, largely built with these funds he had made from the formation of Edison General Electric, and then benefiting from the formation of General Electric. Included in this picture is Edison, his improved phonograph in front of him, as well as his assistants, including Charles Batchelor over Edison's right shoulder, looking down at him. Fred Ott, seated to his right. His brother, as well, with the mustache, another Ott, is pictured here. This picture was reportedly taken after a 72-hour marathon session during which they completed work on his perfected phonograph. Over the coming weeks and months, the West Orange complex would be enlarged to handle production of every facet of the phonograph. Companies would be created to capitalize on it, and Edison's name would be all over the press. It sounds a little familiar, doesn't it? Well, that is Edison and the incandescent light bulb. I hope you enjoyed it. Or excuse me, Edison after the incandescent light bulb, the rise and fall of the Edison General Electric Company. I hope it leaves you with a better understanding of Edison's role in the development of the light bulb. I hope it gives you a better understanding. I hope when you look at inventors today, you look at them not as a monolith, but rather think about all of the individuals surrounding them that made their work possible. I will note that Edison's often criticized for Menlo Park and for all the people that helped create this system that went unnamed. I hope that I put names to these faces. I will point out to you that if you are to look, a lot of these men, like Batchelor, Crucy, Bergman, Clark, all received patents in their names during this time period. And so, not fair to say that every single work done during this time period was stolen by Edison from his workers. At this point, I will answer any questions if anyone has any questions. This video will be posted to YouTube. And so if you do have any questions, feel free to drop them there, and I'll be dropping in to basically answer those for you. But again, I thank you very much for attending. I hope you enjoyed it. Reach out by email if you have any questions. Thank you very much. Once again, this was Step into History Digital Edition.